Here's our first lesson on density, and it's something which you probably would have covered before, but it's something which is often overlooked, the importance of this idea. And let me just let me make a start by just referring to you all to the size of objects. If we have a small object, well, it's the size of the object and how much mass it holds. So there's two reasons why an object might be more massive than another object, and that's because one's due to its size. Larger objects often equal, more massive, and the second is due to the type of material. So it's not strange to imagine that actually you can have two different size objects that actually have the same amount of mass because they're of different sizes, because they're different types of materials, or of the same material, a larger object has more mass. Now, though that's useful to bear in mind, it's not very useful if you want to compare materials together. If you want to compare materials together, then what you need to do is you need to say, for a given volume, however large a volume that might be, and you define it, for a given volume, how much mass is there in that given volume? And then for the same, and for another object, for a given volume, the same given volume, how much mass does that object have? So really, the concept of density is saying for the same volume of different materials, how much mass does it have? In other words, it's a mass to volume ratio. That's meant to say ratio. A mass to volume ratio. So there's a very simple equation. Well, let's think about it first as that definition. So mass to volume ratio. So in other words, or if you prefer to think of it in terms of a description, we say to it, it's the mass in a volume of, and that's the mass in grams, in a volume of 1 centimeter cubed. Okay, that's how we defined it. How much mass is there in a volume of 1 centimeter cubed? Or, if you like, you can say how much mass is there in terms of kilograms in a volume of 1 meter cubed. So it could be anything. It could be grams per meter cubed, but these are the ones that we usually keep it into. How much mass is there in a volume of 1 centimeter cubed, grams, and how many kilograms in meters cubed? In other words, of course, it has a mathematical definition as well. Density is the mass per unit volume. And if we have the mass in kilograms, we usually take the volume in meters cubed. And if we take the mass in grams, we usually take the volume in centimeters cubed. And therefore, that would suggest the density either occurs as kilograms per meter cubed or grams per centimeter cubed. So we do have these two, and you'll have to be able to work between them. But bear that in mind. The first point is it's the mass of an object in a given volume, and we define that as either 1 centimeter cubed or 1 meter cubed. And the mass is measured in either a gram or a kilogram. So I hope that gives you a fundamental understanding about it, rather than just plugging numbers into an equation. However, this equation is present and does exist, and we can make it even shorter by giving it the symbols. This is a symbol rho. It's like a P, but slightly slanted, Greek. Mass over volume, and an associated triangle, if you feel a bit more comfortable with that. Fantastic. So let's give it a go then. Let's talk about a very simple example, and that is water. So let's have a box of water, or we have a box which we're going to throw some water into. It's 1 meter by 1 meter by 1 meter, and it has 1,000 kilograms. This is a box of water. Okay, what is the density of water? The question. If you think you know, hit pause. Otherwise, here comes the answer. Well, let's use the equation. Density is the mass divided by the volume, which gives us 1,000 kilograms divided by, now the volume is the length times the breadth times the height. 1 times 1 times 1, giving us 1, leaving us with 1,000 kilograms per meter cubed. Okay, you might see this written as kilograms per meter cubed. I hope with the maths you understand that these are absolutely identical. The -3 implies per meter cubed. Okay, now let's try and work this out. Rather than kilograms per meter cubed, let's try and work it out in terms of grams per centimeter cubed. What's the answer going